So we're going to start looking at some of the core classes that the Maya API uses. And under the hood, one of the core objects is the MObject, also known as the model object. Now, this is a generic class for all Maya types. Every time you see anything in the Maya attribute panel or anything like that, so we've got Maya here, and when we create a new object or something like that, we've got all of these parameters that we see in the wrong button, in the attribute editor and things like that. All of these are MObjects, and basically any of the parameters like radius and things like that, this is an MObject which is converted into a float and so on like that. So every time we use Maya, we create a series of MObjects. Those MObjects are then converted into the correct thing that we need by a series of things called function sets. And this is done because basically Maya will dynamically decide what the object is and manage all of the lifetimes of these objects itself. What we're doing is we're saying, here is an object, we want this to be a float object, a vector object, a matrix object, and then we have to tell Maya to create it as one of those, and then Maya will handle it as it sees fit. So under the hood, everything is an MObject, and then Maya will go through and use that MObject to see what we can do with it. MObjects are never stored, and we don't use them as something that we pass around and things like that often. And again, once we get more depth of the API, we'll see how these work. But for now, think of this as the abstraction that makes all of the Maya API work. And again, if we start to look at the help, you'll see here there's a nice write-up here on what it does. So Maya's internally modeling, animation and rendering objects, as well as all of directory graph nodes and their attributes are referred to as model objects. So as you can see, that's pretty much everything in Maya. We then have these things called function sets, which have the prefix fn, provide functions for manipulating specific model objects. So if we go back and have a look now, I'll talk about the function sets. So the job of the function set is that it is applied to an MObject to say that this is a particular concrete type. So, for example, I've got here everything that's in the dependency graph and the dependency nodes. We can say if the MObject is pointing to a light, we can apply the M function light to that object, and it will give us access to the particular things that a light can do. However, it could also be pointing to some other type of object. We have to apply the function set to see whether it's correct. Typically what we would do is we would query to say what type of object it is, and then apply the correct function set, or we will filter through our objects to get things of a certain type, say give me all the meshes. Then we would apply a mesh function set to do mesh processing. Again, this may seem sort of slightly odd in the way it's doing it. It's a kind of runtime polymorphism, I guess, but it's doing it in its own way. And again, you've got to bear in mind that under the hood, Maya is trying to optimize everything to make it as fast as possible. So Maya's memory management and object management is optimized for speed and for the way Maya works. It's not necessarily optimized to make it easy for the programmer or the developer to do something, because with all DCC tools, what we want is high performance and throughput. Now, there is limited overlap between function sets. So, for example, we've got to say here, it may be that we've got a light. It's also going to have certain things that are common across all nodes. So again, if we go back to looking at our sphere, what we've got here is a transform. So we can apply the function sets for things to do with the shapes, and we've also got the function sets to do with what this mesh object is, as it were. So there are a series of function sets. all of, again, if we go to the documentation and we start looking for all of the different API elements, and if I can find where they are, there is a list of all of the different objects and function sets. It's not there. When we get the whole C++ documentation, you normally have a list. Here we go, MFN class references. So everything that's a function set lives within here, and you can see there's all sorts of different MFN classes. So every one of these is a type of function set. So you can see camera, camera set, character, clip, DAG, node, data, dependency node. There's a lot of these. And when we sort of go through our entire class list, so here's our list of all the classes here, you can see there's a whole series of these objects. That's the better one. So MA, what we'll find is MFN, and you can see there's all the MFN classes. And you can see there's a lot of function sets, and basically this is what we will apply to go through to do things. So I've listed a few that we may use a lot. So DAG node, these are the visible components in the UI. We've got the dependency node, which are the no visible components in the UI. So we can go through and we can grab elements from the DAG by applying a DAG function set to it. We can go and get things from the dependency node. We can convert a NURB surface or a mesh or something like that. Over the next few lectures, we'll begin to see this in action a lot, because this is the core workings of what Maya does. We create an MObject, we apply a function set for a particular type of thing to be able to access the functionality. Mentioned previously, an object can be compatible with more than one type of function set. So for example, a NURBS object is compatible with or can be operated by the NURBS surface, the DAG node, and the dependency node. There's most really a few others. It depends on the object as you go through. Again, determining which is which and how to apply them is all part of the sort of bigger picture of learning the Maya API and getting everything to do what we want to do as we go through. The next big set of elements we have are the proxies. The job of the proxies are basically we inherit from them to create new types of Maya objects. And in the first set of lectures, we're just going to use this one, the MPX, short for proxy, command. This allows us to create new commands. So anything in Maya that you may sort of type in the editor. So in here, I've got mel up at the moment. So if I just say sphere, press enter, that's a Maya command running. So that's just created nerve sphere there. If you're used to the Python API, cmds.sphere, like that, and you run it, we'll create a new sphere. So if we want to write a command, cmds.myCommand, that's what we would use to generate that. We'd use the npx command. If we wanted to create a new node, so for example, we're going to look at locator nodes. We're going to look at creating a node that does some basic sine wave generation and things like that. Then we would inherit from npx node. If we want to do a deformer, we'd go from the deformer node. If we want to do some IK solving, then we'd create one of these. And file translators are for imports and exports. And again, we'll look at an example of these. So the key thing is proxies understand Maya's internals and allows us to implement new and unique features. And again, it's one of those core parts of the API. We've also got iterators. So the job of the iterators is to allow us to traverse the data structures. So for example, if we want to iterate over a series of keyframes, we would grab the object that we want to iterate over. We'd apply an iterator to it, and then we say get next item, get next item, and it would just give us the next thing until we get to the end of the list. So again, this gives us the ability to traverse the internal objects. In particular, what's useful is the dependency graph iteration, so that we can iterate over all nodes in the graph, and we can also go over the dependency graph as well. So it's a very powerful tool. We'll look at certain examples of how we do this again in later lectures. There's also a series of sort of utility classes that wrap up some of the functionality. Again, a lot of the stuff that you may see in the UI and things like that. So MGlobal is a static class that wraps up a lot of the UI related tasks. So messages and warnings and errors, we can use that for communication. MStatus is going to pass around the internal status codes that Maya does every time we ask it to do something. Now, it's really important that we check these, because if we don't, we may be passing data up or down a chain that is an error message. And a lot of the time, what we want to do is check something and go, that didn't work, and report a fail. If we don't check these things, then we can let things carry on. Maya will crash. Maya will crash anyway. mstring is an implementation of a string that Maya uses internally. mstring obviously predates a lot of the more modern C++ things like stood string view and things like that. So it's got a lot of quirks, shall we say, to be nice. We will look at mstring because it's useful to use. It's not the nicest string implementation in the world, I will say. We've got all of the vectors, we've got the float types, we've got the array types, we've got DAG objects and things like that. So again, as we go through, I'll gradually introduce a lot of these new classes as and when we need them. I would say one of the big things that's also worth noting about the Maya API, that a lot of the classes are what we call array classes. So if I go back to my download of the Maya dev kit, wrong folder here, and if we go into include Maya, so this is all the stuff, you can see here there's a lot of array types. So float array, float point array, float vector array. Under the hood, Maya will manage arrays itself because it's far more efficient for it to do it than us to do it. So a lot of the time when we're passing data around, we are going to be generating these as Maya arrays. Then we will be applying Maya array function sets to them to go through and start processing them. And again, it's just something to bear in mind that the way that DCC tools work is they want to have data in a certain way so that they can process it quickly. They can apply SIMD and other parallel processing type things on it. They can also then manage the underlying memory and do copy on write and all sorts of other sort of very complex things to allow our data to be processed quickly. So we need to use these types. We shouldn't be implementing our own. We should be letting Maya do all the work. So again, we'll get back and look at a lot of these as we go through.